lovely. Ooh, that's an aggressively large marker. Okay. We talked about the exclamation mark. What was the exclamation mark?
It's like the decreasing rock.
It's decreasing rocket counting. So it'd be 5 times 4 times 3 times 2 times 1. Now, if I didn't have the 1, could I still use factorial symbol? Look at the math of this. If I didn't have the 1 at the end, could I still use 5 factorial?
Yeah.
Technically, I could. It's supposed to go to 1, but I could use 5 factorial if I had 5 times 4 times 3 times 2, because multiplying by 1 doesn't do anything, correct? So technically, without the 1, I could still use the factorial symbol. We agree? Now, wouldn't it be nice if it was always numbers? But what if it's variables? Let's look at these. So, it's not that bad. Chillax, I promise. Okay, so if we have an n factorial, we would start at n and then just go down by 1 each time, correct? So it'd be n times n minus 1. 1 less than that is n minus 2. 1 less than that is n minus 3, n minus 4, n minus 5. And you could put ... or you could put a factorial symbol at the back of it, which would mean it would just keep going. Do you agree? Okay. So, which is bigger? N plus 3. Which one's bigger? Thank you. Because if n was 2, this would be 5. We agree? Okay, what's bigger? N minus 2. N's bigger. We agree? So here it says, simplify the following expression, leave the answer in product form where appropriate, which means you don't need to expand it. So if I have n plus 2 factorial over n factorial, if I ever have factorials over each other, what I want to do is I want to take the bigger one and expand it. So which one is bigger, n plus 2 factorial or n factorial? N plus 2 factorial. And the reason why I want to expand the bigger one is because when you expand the bigger one, it actually becomes the smaller one. What the heck does that mean? Well, let's try it out. So n plus 2 factorial is n plus 2, then what? N plus 1, then n plus 0, or just n. And then it would be n minus 1, n minus 2, n minus 3, n minus 4, correct? But I'm just going to put a factorial symbol because it would mean it would just keep going. Why did I stop there? What's in the denominator? You have an n factorial in the denominator, don't you? So what can we do with these now? Cancel them. And my answer is just n plus 2, n plus 1.
Will we ever have to expand that even? Like, do we just...
By example 2, yes. Okay. For B, you try it out. Which one's bigger?
N minus 1.
N minus 1's actually bigger, so that's one you're going to expand. Try it out.
Does it keep going in either direction?
Okay. If you had the value of n, it would end up stopping at some point, right? Like if n was 5, it'd be 4, 3, 2, 1. Stop at 1. It's just that we don't know what n is, so we have n could be 1 million. So for a long time.
N minus 1, n minus
2, and then it matches the top, so you're going to put a factorial. Because you could go, now I'm going to show you another way. You could do this. You could go, and I'll show both, n minus 1 factorial, or n minus 1, n minus 2, n minus 3, like I could keep going, put a factorial there, and then go n minus 2, n minus 3, and then put a factorial there, and then these two would cancel, and I'm left with 1 over n minus 1. Like I could keep going further if I wanted to, right? Or I could just do what I taught you up top and do n minus 1, this is the way I always do it, n minus 1, 1 less is n minus 2 factorial, because I stopped there because it matches. And then just cancel, and I'm left with 1 over n minus 1. I always do just till it matches the top myself, but you could expand this one further and expand this one further and then cancel off more if you really want to. What's the catch with C? The denominator doesn't have 1.
Oh. Exclamation point.
Doesn't even have a factorial, right? So it's the only one I can expand. The top one. Try it out. So we let everyone try it out, Max. And no. So the only way you can get factorials to cancel is if you have factorials in the top and the bottom, correct? Which I don't have. But I can expand the top to be n minus 1. Now I'm not going to go factorial because this one doesn't have a factorial. Watching, I'm going to show you which would be what would be bad. If you did this, n minus 1, and you canceled these off. Can I do that? This one is an n minus 1, it's just an n minus 1. This one's an n minus 1 with a factorial symbol. So that actually means n minus 1, n minus 2, n minus 3, n minus 4, n minus 5. Correct? Does this one have a factorial? No. So I can't do it by stopping like that. I have to go n minus 1. That actually matches that one, correct? And I have to go one more. N minus 2 factorial. Then I can cancel these off because they actually match. My answer is n minus 2 factorial. So if both your numerator and denominator are not factorials, the factorial symbols can't just cancel off because you're going to have to keep going somewhere. Does that make sense?
In 1A, will we go x squared?
No, not for now. We will in this one. Okay, example 2. Example 2 is different than example 1 in the fact that it has equal to a number. Do you see that? But we're still going to treat the left side just like we did above. Okay? So which one is bigger? N. So I'm going to expand this one out. So I'm going to rewrite it. I'm going to expand the n factorial out. I'm going to go n minus 1, n minus 2 factorial over n minus 2 factorial equals 42. And then those cancel. Do you see that? Yeah.
I don't even know, like, if you should just stop there. Or
Once it matches the numerator or denominator, I stop.
if
So
you
I
really
always
get
expand the
minus-
bigger one.
If you really get n minus 3 on those, like,
If this was an n minus 3, I'd stop at n minus 3. I would go n minus 1, n minus 2, n minus 3 factorial, cancel them.
are you wrong if you expand it more?
If you expand more, as long as you cancel off till you have n minus 1, no. So like if you went n minus 1, n minus 2, n minus 3 factorial, n minus 2, n minus 3 factorial, those canceled, I'm still left with n minus 1, you're totally fine. Yeah. Now this is the key thing here. We have n and n minus 1, so we're going to have two numbers that are going to get me 42. One's going to be bigger, and one's going to be one less than that. So I know it's going to be 7 and 6, just by guessing and checking to get me 42. But that is not algebraically. And if they do this on a diploma and you don't actually solve this algebraically, you're going to get like 1 out of 2. So we have to actually do this algebraically. So what are we going to do over here? Distribute, yeah. N squared minus n equals 42. Now we're just in grade 11. What do we do in grade 11 if we have this?
Put to one side.
Get it to one side equal to 0. So what multiplies to give me negative 42 and adds to give me negative 1? N minus 7 and n plus 6. Now this one's going to be n equals 7 and this one's going to be n equals negative 6. Now n can never be negative 6. Because a factorial symbol starts at a number and rocket counts till I get to 1, correct? Can you ever have negative numbers in a factorial? Can you do -6 factorial? No, it stops at 1 factorial is the very minimum one you can do. And 1 factorial is just 1. So this is extraneous. And then we can check and see if this makes sense. We'll type it in. So we're going to go in a fraction, 7 factorial. Remember how to get it? We're going to go, I'm going to go alpha link, but 7 factorial, math over to probability. I arrow to the left because I get there faster. Number 4 over 7 minus 2 factorial. If you have the old calculators, you just have to make sure to put it in brackets. And I get 42. So I know I'm right. Can everyone find the factorial symbol? Do math. 4.
What did we plug in again?
You're just checking it. You're plugging in 7 into the left side to see if it equals 42. It's also a solving. Could I y1, y2 this? Is there an equal sign in one variable? In that original question, is there an equal sign in one variable? Yeah, I could y1, y2 check it. It would be wonky, but I could check it anyways. So we're going to go over the permutation formula. The permutation formula is NPR equals n factorial over n minus r factorial. It's on your formula sheet. It's right here. So this is from this last unit. So this is the n factorial, NPR, NCR. This is the unit we're on right now. Perms, commons, and final. A permutation order matters. We're going to write that. You often arrange things. So if order matters in which you do something, it's permutation. So the PIN number on your bank card, does the order matter in which you type it in? Yeah. If your code is 1234 and you put in 4321, you're not getting in, right? So that's a permutation. What about a license plate? Does the order matter in which the letters and numbers happen? Yep. What about a phone number? Yep. What about taking out books from a library?
What?
Taking out books from a library. You go to the library, you have to take out 4 books. Does the order in which you take out those books matter? No. You go there, they go, you take your books, throw them in a backpack, and you go home, correct? What happens, though, if you're a really terrible library goer and you're only allowed to take 1 book out a month, but you really want 4 books? You want these 4 distinct books to read, but you can only take out 1 book a month.
Steal them.
Stealing them is not an option. Then the order matters. If you can only take 1 book out at a time, the first month you would have 4 options of a book, right? Then you take 1 out. Then the next month you'd have how many? 3. Then the next month. Then the next month. So that's a permutation. Order would matter. If you're picking people for specific positions, like president, vice president, and secretary, does the order in which you pick them matter? So if you're picked first, you're the secretary. You picked second, you're the president. But you really want to be the president. Does order matter? When you're giving people specific jobs, does order matter? Yeah. If you want to be president, you're not very happy. I was going to say a different word. If you got secretary, that would be a problem. So when you give people specific positions, it's a permutation. Now, how's the difference? This can be the difference between permutation and combination in that instance, okay? So say I'm picking 6 people to go on a trip, all right? 6 people get to go on a trip out of this class. Not you. 6 people get to go on a trip out of this class, okay? That's all I have for stipulations. Does the order in which I pick those 6 matter? No. You just get to go on the trip or you don't, right? But what happens if I say 6 people get to go on a trip out of this class? First person picked gets to pick where you get to go. Second person picked gets to pick the food. Third person picked gets to pick who to sit with. Fourth person picked gets to pick up the garbage. And fifth person picked gets to just say hello to every person he sees.
Right under the bus.
Right under the bus. Okay. Does the order in which you're picked matter then? Yes, you're giving them specific jobs. So it's the same thing as being president, vice president, secretary. Order would matter. Okay? So if you give jobs or different roles to the people, then it's a permutation. If you just take them on the trip or you don't, then it's a combination. Order doesn't matter. Okay. Every single time you're doing a word, does the order matter in words? Yes. Because if not, I could be pill instead of left. See how I was just doing that there? Hell. Or I could be hellep. Or I could be poop. Or I could be poop. Or there's not very much arrangement with 4 letters. I could be plep. That sounds normal, but I could be poop, which is like I have 2 P's. I was trying to put them together. I was really trying to pronounce it. Pronunciation on the wrong syllable. No? Okay. Okay. So, words order matters. Or I could be called Pelp. Yeah. Mrs. Pelp. Yes. That'd be terrible. All right. I thought Lepp was terrible, but Pelp is worse. Okay. Let's go here. So, this is where that formula comes in handy. Are you ready? Determine the number of total objects objects you have to choose from. If, when arranging 3 of those objects, it results in 1,320, it's going to be a real good day, distinct arrangements algebraically. So they want the number of objects. So this is what we have to do. NPR is the formula that I just showed you on the previous page, correct? What the heck does this stand for? Well, N is the number of total objects. And R is the number of objects chosen. So if I was doing the question that I just said, where I took this class, there's 24 of you, and I chose 6 of you to go on a trip, and I gave you all those different jobs. One of them was getting to choose the trip, one of them was riding under the bus, I don't even remember what I said. One of them was picking food. You know where I gave them all different jobs? N would be the total number of objects. How many objects are in this classroom? You could be worse things, okay? Objects is not that bad. So there are 24 of you, and I picked P because what question I gave you was a permutation, correct? There's 24 of you. I picked 6 of you in a specific order to go on this trip, correct? So the R is how many I chose. How many did I choose? 6. So we can learn how to type that into our calculator. So we're going to go 24, and then you're going to go to the same spot you found the factorial. 24. 24, 2, and then 6. Some of you will have 24, NPR, 6. It's the same thing. So that's how many different groups, 6-person groups I could pull from this class. So you have a, yeah, so picking 6 of you from the group and giving you that specific job though, right? That's the difference. That's why there's so many more. Right, so if I didn't give you specific jobs, it would be 24 math C 6, which would only be that many options, 134,500. So that's still a lot, but that's 6 different people all the time being picked, how many different groups I could make. But there's substantially more when you have to get a specific job, right? Yeah. Okay. So this question here, instead of me giving you the total number of objects and the objects I'm picking and get an answer, this question I gave you the answer. So here it says, Here it says determine the number of total objects. So what's it making me find? N. Now I have to decide if it's a P or a C. We're in the permutation lessons, so I'm going to bet it's a P, but let's figure out why. So it says the number of total objects you have to choose from when arranging. If you're arranging something, you're putting it in a specific order. You're giving it order. So if the word arrangement is anywhere in the question, it's a permutation. It's a dead giveaway. Okay? So we're arranging 3 of those objects. So what did I give you? And we don't know. We're looking for it. We're arranging 3 objects out of the total number of objects. What did I give you? Which letter? R. And it results in this many arrangements. So I gave you the answer. Right? I gave you what it equals, didn't I? We know it's a P because of it being arranged. So when we do the formula, it's going to be NP3 equals 1,320. Now, N just needs to be what? 3. What does N have to be as opposed to the 3? It has to be greater than 3. Or, what else could it be to 3? Equal to. I could have 3 objects, pick 3 objects, correct? Or I could have way more objects, pick 3 objects. So the key thing about N and R, I'm just going to write up here, is N has to be greater than or equal to R. Because N has to be at least what R is, right? You can't have like, I have 2 objects, I'm picking 7. You can't do that. Like, it's not allowed, right? Okay. So you could guess and check with your calculator, but if this is on an algebraically question or if this is in a written response, the guessing and checking will help you, but you have to solve it algebraically. Now the formula is where you're going to have to go after this. The formula is this. NPR equals n factorial over n minus r factorial. That is the formula. So instead of writing NPR or NP3, I'm going to fill n in for n and 3 in for r. Do you see that? So I'm going to go n factorial over n minus 3 factorial. The n stays an n, the r stays a 3, right? Like I'm just literally filling it into the formula. Does everyone understand what I just did? And it equals 1,320. What am I going to have to do after this? Yeah. I bet you know. We just did this. What did we do? Yeah. Yeah, you have to expand the bigger one to make it be the smaller one, and then they cancel. Which one's bigger between n and n minus 3? N. So we're going to get n minus 1, n minus 2. If you haven't noticed, we're getting a polynomial. N minus 3 factorial over n minus 3 factorial equals 1,320. If this is not algebraically, would going 3p3, 4p3, 5p3, 6p3, 7p3 be faster? Like guessing and checking in your calculator? If this was a multiple choice? Yeah. Because what we're going to end up getting here is we're going to expand that in. So we're going to get n squared minus n, and then n minus 2. Then I have to expand again, so I'm going to get a cubic. N squared times n is n cubed. N squared times negative 2 is negative 2n squared minus n squared plus 2n minus 1,320 equals 0. Because I have to get it equal to 0 if it's a cubic, quadratic, quintic, quartic, whatever. I'm going to get n cubed minus 3n squared plus 2n minus 1,320. How do I get to factoring that? Yeah, it's plus 2n. I would have to, what?
I don't know if this is right, but isn't that like box thing?
Yeah, synthetic division, aka the box thing. Yes. You sounded like you hurt yourself. So you would just have to type it into your calculator and do it, correct? I'm just showing you how you would get to this point, and then you just have to literally go punch this into your y1, and you look for an x-intercept to do synthetic division, right? Yeah. Yep, type it into your calculator. Go to your y equals. Type in x cubed minus 3x squared. You can. We're going to x cubed minus 3x squared plus 2x minus 1,320, which is your y-intercept, which is a little bit cray-cray. So I would use 12. It's the only option. What's 12p3? Type it in your calculator. What's 12p3? There's the answer. So you would show it in your synthetic division and the front x equals 12. Boom. There you go.
So you have to show it, even though that's the answer.
If it says algebraically, yes. I've never seen them give a cubic this way. It's always been a quadratic like we did on the previous one, but I just want to show it just in case you get something.
I really hope we don't.
I hope you don't. But there's worse things in life than that. Okay. So, oh my gosh. I want you to try this one, please. N minus 1 P2 equals 90. So you're going to have to fill it into the formula that's above. Right. So you have to fill N minus 1 in for the N's and 2 in for the R's. This goes in for N. Ooh, it's an aggressively large marker. And that goes in for R. Then you need to solve. Okay, we're going to get N minus 1, N minus 2, N minus 3 factorial. Okay. So we're going to get N squared minus 3, N plus 2 equals 90, N squared minus 3, N minus 88. So it's going to be 11 and 8. N minus 11. That is a 3. I said 11. I have no idea. Sometimes my brain goes places. Okay. And then N plus 8. So N equals 11 is good. N equals negative 8 is extraneous because you can't have a negative M. Because negative 8 minus 1 is negative 9. Not helpful. That means you have like less than 0 objects. So this is extreme. Okay, your homework is this. Uno. Dos. For B, can we look at B for a second? This is not helpful to us this way. What have we always been dealing with them? Stacked, correct? Can we make it? Yeah. We should divide it over to make it stacked. So our first step is going to be doing this. You will not have enough room in these spots if you, well, it's not a challenge, but I guess you can take it as a challenge. All right. 2. And then I just want you to do, and 3. I took off the ugly ones. Look at me being so nice. I forgot I took them out of the notes. 1, 2, and 3. Yeah. It's going to be due on the Friday. So D, what I can do is I can also divide the n minus 1 over, which would mean it would join the n minus 2, wouldn't it? What's n minus 1 times n minus 2 factorial? What if I just add the one in front of it to it? What's n minus 1 times n minus 2 factorial? That would be n minus 1 times n minus 2 times n minus 3 times n minus 4 times n minus 5 times n minus 6. What is n minus 1 times n minus 2 factorial? It's just n minus 1 factorial. Equals 20.
With the top one, would you be like, would the next one be n plus?
Which one, sorry?
Or would be like, would the next one be n plus 2? Like it is.
No, it has to go downwards. So n plus 1, then n minus 1. Yeah. So this would end up just being n plus 1 times n, because they'll cancel, equals 20.